Alright guys, welcome back. So in this second video this week, we're going to start a new topic. So in particular, we're going to start the topic of arithmetic series. So before I can tell you what an arithmetic series is, really I have to tell you what a series is. So a series is a really simple idea. So you know what a sequence is, right? A series is really just all the numbers in a sequence up to a certain term added up. So we'd call the series, we'd label it Sn, is the sum of the first n terms of a sequence. So for instance, let's say I had the sequence that looked like 1, 2, 3, etc., right? My favorite sequence, it would seem. And let's say I wanted to know what S3 is. So given this sequence, what would the series S3 be? That would just be 1, right? So term 1 plus the second term, right? The first n term, so 1 plus 2 plus 3. So all I'm doing is adding this number plus this number plus this number. 1 plus 2 plus 3 is equal to 6. So really that's a pretty simple idea, okay? So if that's what a series is, it would make sense that an arithmetic series would be the sum of an arithmetic sequence. Okay, so let's jump to an example now. So really, I just gave you one example. This was an arithmetic series because there was a common difference of 1, right? But now I want to do a much more complicated example. So I'm going to kind of set you guys a challenge here. So I would like you guys to try to work out what, if I have the sequence, the same sequence, 1, 2, 3, 4, 5, I'd like you guys to work out what S100 is, right? So what this means is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus etc. all the way up to 100. Well, how on earth could you do that? Well, you could sit there with your calculator for a while, but you'd get pretty bored pretty quickly. So what I'm going to do is work this out for you. So I could say S100, right, is 1 plus 2 plus 3 plus etc. all the way up to 98 plus 99 plus 100, right? Okay, so I could say that. I could also say, alright, and you guys are going to think I'm nuts for doing this, and that's okay. You're free to think that if you like. I could also say it's S100 plus 99 plus 98, and you're thinking right now, well, Josh, writing it out the other way around isn't really going to help you, right? But 3 plus 2 plus 1, and you'd be wrong about that. So S100, S100, right? I can add these two together, yeah? There's no reason why I can't. I can add these two equations together. What would I get? So S100 plus S100 must be 2S100, right? And now I can add each of these terms. So 1 plus 100 is what? 101. 2 plus 99 is what? 101. 3 plus 98 is 101. All these things will add up to 101. So all the way up to 98 plus 3 is 101. 99 plus 2 is 101. 100 plus 1 is 101. Okay, so maybe I'm not completely nuts. So how many times did I do this? Well, 101, right? There are 100 terms in this sequence. This must be 101 times 100. So now I can divide both sides of this equation by 2. Divide by 2 to give me S100 is equal to 101 times 100 divided by 2. Alright, so that's the same thing as 101 times 100 divided by 2 is 50, which is equal to 5050. So that's pretty amazing, isn't it, really? So what I did was I gave you a really hard problem, S100, right, to add up all the numbers from 1 to 100, and pretty quickly I was able to work out that that would be 5050. So hopefully less boring than sitting there with your calculator and adding 1 plus 2 plus 3 plus 4, etc., all the way up to 100. Okay, so that's one example. Now let's work on a different one. Now I want to give you a different sequence, so I'm going to give you the sequence Tn is equal to 2n, just to be slightly different, right? So that would be if n is equal to 1, 2, 3, our sequence would be 2, 4, 6, 8, etc. Right? So if that's our sequence, and this is just going to be completely random, I'm going to say I'd like to work out, say, the series S33. So 2 plus 4 plus 6 plus 8, right, until you get to the 33rd time. Okay. So how would I work this out? Well, let's try to use the same trick that we did before, okay? So we'd say S33 is what? 2 plus 4 plus 6 plus da 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 da. What's our last term going to be? It's going to be 33 times 2 is 66, right? So let's work backwards from there. 66 plus 64 plus 62. Now I can also write this the other way around, right? 66 plus 64 plus 62 plus da 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 da. 6 plus 4 plus 2. Now again, I can add these two equations together. And what do I get? 2s33 is equal to 2 plus 66 is 68. 4 plus 64 is 68. Right? They're all going to be 68. Just like they were all 101 before. 68 plus 68 plus 68. And how many copies of 68 do I have? Well, it was 33 terms in the sequence. This would be 68 times 33. This was 2s33. So I can again divide both sides by 2 to give me s33 is equal to 68 times 33, right, divided by 2. And you can work this out on your calculator, but you should get, let's see, well, 34 times 33, what's that? 34 times 33 is equal to 1122. Okay, so again, that's pretty neat, right? Well, what I'd really like to do is for any arithmetic sequence, so we just did 2 of them, right? I'd like to work out one formula that we could use for any arithmetic sequence. So let's think about what that formula might be. So for any one, right, we should have, let's see, we'll have a first term and we'll have a last term, right? And then every term, when we do this thing here, right, we should get the first term plus the last term every time, right? So it makes sense that, let's see, Sn should involve something like t1 plus tn, right? The first term plus the last term. And I should probably do that n times, right? So n times. But then remember, we always had to divide by 2 as well. So n divided by 2 times t1 plus tn. So that's what I reckon. I'm going to put that in a box because it's important. What I'd like to do now is basically just go ahead and check and make sure that this is actually going to give me the same answers that I got before. So let's take tn is equal to n and work out S100 again using this formula now. So how would I do this? So S100, right, would have to be, well, n is 100, so that's 100 divided by 2 times, well, t1, right, is 1, tn, so t100 is 100, so this is equal to 100 divided by 2 is 50 times 100 plus 1 is 101. This is 50/50, right? So that's check. It agrees with what we got before. So now let's do the sequence that we did before. Tn is equal to 2n, right? So we know here, and let's work out S33. So we know T1, right, is equal to 2 times 1 is equal to 2. T33 is equal to 2 times 33 is equal to 66, right? Now let's plug that into our formula that we just had. So S33 we reckoned was n divided by 2, so that's 33 divided by 2 times the last term, T33 is 66, plus the first term, 2. So this is 33 divided by 2 times 66 plus 2 is 68. And this is, well, you should probably see that it's the same thing as before, but 33 divided by 2 times 68 is 1122. So that's good. So we've checked now for 2 different series at least that this formula that we came up with is the correct one. And in fact, this is the right formula for any arithmetic series. It's a general formula that you can use to solve a whole bunch of different arithmetic series. Alright, that's all for that video. I'll see you guys next week.